if you can understand capacitance, you can understand much of electronics and physics. A capacitor is basically the ability to store an electric field between two plates. So I've just built this one. This was my first attempt, didn't work very well. And this actually now stores a voltage. It's the most simplest thing ever. So I'm going to show you and tell you how to do this, because I think it gives a great understanding. So I've used something that has a big surface area, because the formula for capacitance is the surface area of the two plates, the distance between them, the dielectric material that I'm using between them in this instance is paper. And what happens is, when you've got two plates, conductive plates, you measure the surface area, you pass a voltage through using a power supply or a battery, and what happens is, because the electrons are negatively charged, you get a build-up of electrons on the negative terminal, or one side of the plates. Those electrons build up, and what happens is, because you've got less electrons here, more electrons here, because all the atoms have these electrons orbiting around them, so whatever atoms are in this aluminium paper, of aluminium and different metals, the electrons that are around them build up on the negative side. And what happens is, it's like a seesaw. You get more on this side, so the seesaw, the electric field wants to move across. Now, it's kind of like a balancing act, because you really want a good dielectric. Like if I make a really big one, I want some plastic in the middle. The electric field isn't stored kind of inside this material. It's just that the plates are on it, so it appears or feels like the electric field is stored in this material, but it's stored between the two plates. And you don't want the electric field to move across the two plates, because it would just be a conductor. So by having an insulator in the middle and my hands in the two plates, the electric field wants to go across. And as soon as you connect the two ends of the capacitor, as soon as I connect them to an electric circuit, the electric circuit will then get the voltage. So I'm going to show you how this works. The key that I've done here, I've wrapped just this foil with the paper in the middle. I've just wrapped it around, because the more of the surface area you have that's covered, the more surface area I have that acts as capacitive plates. And the formula for capacitance is the permittivity of the material multiplied by the area of the plates divided by the distance between them. So it's a really, really simple formula. And the more terms we add n, we can just add that into the formula. And capacitance for me unlocks the kind of secret world around us that we can't see. If you can understand this, you can understand how transistors work, because they rely on small amounts of capacitance. These Peltier modules I've got lying around everywhere. A lot of electronics, including electromagnetism, is based on how an electric field forms. And for me, this is the simplest way to explain it. N number of turns, slightly more diameter in the paper. Now we're going to try it. Okay, we've just put the capacitor here in this pepper pot. So now if we put 3 volts through this, it would take like a nanosecond literally to charge. That would charge up the capacitor. So there's 3 volts in here. And if we just rogue check the voltage across here, okay, should have 3 volts, 3 volts, 3 volts, 3 volts. When I remove this, the only thing that's going to be going to the ammeter is the capacitance. So here we go. 0.8 volts. So now it's going to discharge, because I've got a resistor across it, but this thing is storing 0.8, almost 1 volt. So 30% efficient. Obviously, it's just a piece of paper and a piece of tin foil. But you could obviously see how you could make this a lot more efficient with much bigger plates and with a much better dielectric than paper. Okay, so just to improve the efficiency a little bit, what you can see, I've squashed them together, because the distance matters, as you know, it's part of the formula. And I've just put them in this small olive oil pot. Obviously it'd be much better if I put the lid on. So I just want to show you now, I should get a slight better, bit more efficiency. So if we put the ammeter on here first. And then we put 3 volts through this. Oh, it's okay, 2.99 volts. 3 volts. Now, if we let go, 1.2 volts. So we stored, obviously it's going to discharge now, but we stored 1.2 volts in this capacitor because we put things closer together and we encapsulated it so the electric field can't get out. These experiments are invaluable because it actually helps you picture where the electric field is inside the capacitor.